In this video, we're going to have a look at rates. Rate is a measure to show how quickly one measurement changes in comparison to another. So here, just like with ratio, we have a comparison between two values, but this time with different units. Just like with a ratio, you can see a rate as a fraction, with quantity 1 and quantity 2. These two quantities have different units. Or you can choose to write your rate in ratio form, and that will be quantity 1 to quantity 2. For both these notations, you will once again have to apply the basic principles that you apply when simplifying fractions. What happens in the numerator should happen in the denominator, or what happens on the left should happen on the right. The ideal when working with a rate is for quantity 2 to be 1. For example, if you think about the speed of a car, the rate will be something like 120 kilometers per hour. This means that our quantity 1 is 120 kilometers for every 1 hour that goes by. Example 1. If a car can drive 220 kilometers in 2 hours, determine the speed of the car in kilometers per hour. So here we are asked to determine a rate. The rate that we want to determine in this case is the speed, and all we need to do is divide the two quantities. The speed is measured in kilometers per hour, so the 220 kilometers will be in our numerator and the 2 hours in the denominator. After simplifying, you will have a speed of 110 kilometers per hour. Example 2. If a bicycle travels at a speed of 0.5 kilometers per minute, how many kilometers can the bicycle cover in 2 hours? In this example, the rate is given as speed of 0.5 kilometers per minute. That means our quantity 1 will be in kilometers and our quantity 2 will be in minutes. The question is, how many kilometers can a bicycle cover in 2 hours? This means that we first need to convert the 2 hours into minutes by multiplying by 60, and that will give us 120 minutes. Now we can substitute the 120 minutes in the denominator. Now we need to do a bit of algebra. We want to solve the kilometers, and that means we want to get rid of the divided by 120 minutes. To do that, we will have to multiply by 120 on both sides. So on the left, we multiply by 120, and that will give us the number of kilometers on the right-hand side. Therefore, the number of kilometers will be 60 kilometers. You could also have chosen to rewrite this rate in terms of a ratio by saying you have 0.5 kilometers for every 1 minute. In the question, we were given 2 hours, and we've already converted that into minutes as 120 minutes. Next, you need to determine what happened on the right-hand side so that you can repeat the calculation on the left-hand side. And clearly, we multiplied by 120, so we also multiply by 120 on the left, and that will give us the 60 kilometers. Example 3. A car can drive 11 kilometers on each liter of petrol. How many liters are needed to drive 165 kilometers? From the given information, we know that the rate is 11 kilometers for each liter of petrol. From this, we know that kilometers will be in our numerator and liters in our denominator. and we are asked to determine the number of liters if 165 kilometers are driven. If you are familiar with solving an equation like this using algebra, you can use algebra to solve the number of liters, or you can choose to rewrite it in ratio form again. We have 11 kilometers per liter as our simplified rate. Next, we are given 165 kilometers and we want to determine the number of liters. In lesson 3 on ratios, we saw that when you want to determine a specific value in the ratio, you start off by taking the known value and dividing it by the number of parts it represents. This you then multiply with the number of parts on the other side. 165 divided by 11 is 15, and 15 times 1 is 15 liters. I'm reminding you that we divided here because then we know that when we do the opposite calculation, we will multiply by 15, which means we will also have to multiply by 15 on the other side. Example 4. Water is drained from a tank at a rate of 20 liters per minute. Question A. If there are 1,400 liters of water in the tank, how long will it take to empty the tank? I'm immediately going to start off by writing our given rate in terms of a ratio. And here we have 20 liters per minute. We are given that there's 1,400 liters of water in the tank, and we can write this on the left hand side and then determine the number of minutes. Just like in the previous example, we are going to start off by taking 1,400 and dividing that by 20 so that we can then determine what the change was that happened on the left hand side, and that is 70. Now we multiply by 70 on the right hand side, and that will give us 70, which means it will take 70 minutes to empty the tank. Question B. It takes 24 minutes to empty the tank. How much water was in the tank originally? Once again, we start off with our simplified ratio, and then here the minutes were given as 24 minutes. So 1 was changed to 24 by multiplying by 24, and the same calculation should then be done on the left hand side. The reason for this, there were 20 liters drained or removed from the tank 24 times, and that is why we multiply. If we multiply by 24, we get 480 liters. From these examples, you could see that even though a rate compares values with different units, whereas a ratio compares values with the same unit, the calculations for both are exactly the same because both of them can be rewritten in fraction form.